fine. Good morning all. Today let us have a discussion on OLAP cubes. These are also called as data cubes, online analytical processing cubes. See here now, by seeing this diagram, we come to the conclusion that it is of many dimensions. It is of many dimensions. One dimension it shows this. This is a date, means a time, first quarter, second quarter, third quarter, fourth quarter, like this. Okay, and this dimension it is for product. Which product? Okay, like TV, PC, VCR and total. Okay, so this is related to that. And if you take this column, this dimension, it will give you the country. Got it? What? India, Nepal, China and total, like this. See here now, here example I will tell you. Okay, in the first quarter, okay, how many this TV product, TV is sold? What is this total? Okay, sum of this TV. Okay, I'll take it as example, I'll take 10. Then in second quarter there are 15 TVs are sold. Okay, and third quarter again it could be 10, and in fourth quarter it is like a 20. Okay, these are TV sold in first quarter. First quarter means January, February, March, these 3 months. Then April, May, June. Then 10 TVs in. Then what is that? July, August, September, and here October, November, December, 20 TVs. So how many total? 10 plus 15 plus 10, so 25 plus 10, 35, 35 plus 20, it is 55. It is 55 TVs are sold in a particular year. Okay, that too, which is this? In India. We are talking about in India. Got it? So in Nepal again it is different. Then China, and assume that total 55 TVs are sold in this, where in India, and assume that there are 60 TVs are sold in Nepal and 100 TVs are sold in China. So what is the total? 55 plus 60, it is 115. 15 plus how much it is? Assume that 100 plus 115, it is 215. 215 TVs are sold in total for all the countries for a particular year. See here now, just now we are talking about only, what is that? Which this thing? TV product. So like this, you can have this, and you can have this, and you can total. So total in first quarter, how many? Assume that there are 100 PCs are sold and 200 VCRs are sold. Assume that 200 VCRs are sold. Then 10 plus 100 plus 200, this is 310. In the first quarter, how many products are sold? 310. Okay, this is in India. Got it? So if you take like this, second quarter, third quarter, fourth, it gives you, this will give you all the things. Got it? Assume that it is having, directly I am writing here it is 200 total sold, products sold is 200 in the second quarter, 300 in the third quarter, okay, and again 100 in the fourth quarter. Okay, if you take this 300 plus 200, 510, then 810 and 910, total 910 products are sold in India. Got it? This will give you 910. Then if you take this like Nepal, how many products are sold? Then in China, how many products are sold? If you add all these things, here you will get all over the country how many items are sold. Got it? So here it is the amount. Okay, so this is amount or whatever. So here this and this, you will get some values. So this is what the in many dimensions. See here now, just now we have seen only 3 dimensions. One is product in this way, and second one is a time period, and here it is a country. Okay, there could be another dimension here, there is another dimension over here, and there is another dimension over here. So you can see all those dimensions. So much of data can be stored, and you can access those information. Got it? This is what the data cube is. Now see here now, why we need to go for data cubes? Here we stored some data here in the form of table. See here now, what is table? Table which is having the rows and columns. Now assume that this is a row 1, this is row 2, and this is row 3, and this is column 1, column 2, and column 3, column 4, and column 5. See, if you take like this, this is looks like a table. Now it looks like a table. This, see, this looks like a table. Got it? Now if you take this, if you take this, now this also looks like a table, because here row 1, row 2, row 3, and row 4 are there, and again row, column, column, and column. Okay, if you take this, okay, this also form a table, because which forms a matrix. Got it? Now 2-dimensional view of sales data I'll take. Example, here I am considering only one location's information. One location information. Here in this table, what I am taking, home entertainment item, and computer as a second item, and phone as a third item, and a security. Okay, these are the item types. Column headings. Got it? Here as a row, first quarter, second quarter, third quarter, and fourth quarter. Time period you can take it however you want, yearly or quarterly or monthly, whatever. Got it? In this example, they have taken it as quarterly. Now in first quarter, home entertainment, there is 605, then 825 in computers. In the first quarter, I am talking only on the first quarter, it is phone 14, and the figure is 400 for the security. These are the first quarter values for the respective items. Similarly for all, 680, 952, 31, 512, like this. Got it? So this is related to only one location information. One location information. Now if I have many locations, okay, in the example below they have taken it as a 3 locations. Here it is a quarterly basis in Chicago, okay, In Chicago, this is the information for home entertainment, and this is for computer, this is for phone, this is for security in the first quarter. Again, in the same, for the same items, for the city is New York. For that, home entertainment in the first quarter 1087, 968, 38, and 870. Then for the Toronto, this we are having this thing again same. Got it? So this is the data. If there are such many countries, such many locations, then how to store these data? Got it? For this we have a concept called data cube. Now we'll see it. Three-dimensional data cubes. Here we stored the information in the form of tables. Best example, weekly I am sending you, what is that? Attendance. What
Attendance list.
Attendance list, exactly. Okay, here in spite of this quarter, you will be having your names. Okay, Akash, Kiran, Leena, Ria, then Snehal, Soumya, Sujit, and Sumaya. Got it? Like this, 8 names will be there, and you will be having the Monday, Tuesday, Thursday, Wednesday, Friday, Saturday. Then for one subject, another subject, again same thing. Like this, we will be having 9 subjects, including lab. Got it? So that can also be represented in the form of cubes. Now, this table form is converted into cube, 3D view of the cube, data cube. See here now. I'll take one example of this previously. Okay, quarter one, and these are the quarter time period. These are the item types. Home entertainment, computer. This is home entertainment, and this is the computer, and this column represents a phone, and this last column represents security. Clear? All these things are item types. Now here it is location. Here it is a location. Now see here now. In this location, Vancouver, okay, which city I don't know, Vancouver, there in the first quarter, what is the figure in that? Home entertainment 605 is there. Okay, see here now. For the first quarter, where it is cursor, yeah. Okay, for the first quarter, for this city, this is 605. Okay, for the computers 825, then it is 14 for this and 400 for security. Got it? Then similarly for Toronto, New York, and Chicago, if you see what is the figure in the home entertainment for the first quarter, see here now, 854, 1087, 818. See here now, 818, Chicago 854, New York 1087, and Toronto it is 818. Like this, see all the countries product wise or item wise, they have stored the information. Got it? Here quarterly, here it is this thing and other dimensions. Got it? So this is what the data cube. Data cube, it holds lot of information. It holds lot of information. As you roll it, okay, see here now, if you this way it is there no? Now if you roll it this side and this side, okay, and this side, now we are seeing this way. Now instead of that, now I'll going to rotate it into this way. Okay, so in this way, So you will get different information. You will get different information. Based on the things, based on the information requirement, we will going to rotate it and we will get the informations. Got it? Now, then what is the definition of cube? What is the definition of cube? The OLAP cube is a data structure. Can anyone tell what is data structure? Can any one of you tell me what is data structure? Soumya.
Data stored in a particular manner or particular structure.
Yes, it is a mechanism for storing the data. Okay, data structure is it is a mechanism of storing a data. Got it? So this is also one of the mechanism. It is also a data structure in which very quick data analysis can be done. In which very quick analysis of the data can be done. A data cube helps us to represent the data in the multiple dimension. See here now. What it will do? It helps us to represent the data in a multiple dimensions. Just now we have seen, we have discussed about it. Okay. So if it is in the form of tables, relation only 2 dimensions, row and column. Okay. Now it is multiple dimensions. Multiple dimensions, it allows us to store the data. It is defined by dimensions and facts. See here now, data cubes are defined by dimensions and facts. Dimension means how many dimensions? Which dimensions you are talking about? Are you talking about this dimension? This dimension? Or are you talking about this dimension? Or are you talking about this dimension? Got it? See, based on the dimensions, it will give you the facts for different information. Got it? See here now, if you see here, where is that? Let me take a different color. See, if I take quarterly and item wise, I'll get the information which home entertainment, which item type and what is the sales. Okay, in the first quarter, second quarter and third quarter, so on. But we will not get the information of the countries or locations or the cities. Got it? So if you take this way, where it is? If you take this way, okay, this way and this way, we'll get the information of the which country and what is the which city and quarterly what is the sales or information of that. Got it? So we'll get different facts. So facts is, it is facts always in the form of numbers, figures. Facts always gives us a numbers. Got it? So it is defined based on defined by dimensions and facts. Facts are nothing but what is that? Figures. The OLAP cube consists of numeric facts. That's what I had told. It consists of always numeric facts. Okay, facts are represented here in the form of numeric, not in the form of stories. Got it? Sometimes you will tell, no, somebody is telling, no, tell me the fact, I don't want your story. Got it? So it is not that. So facts always accurate. Facts always, it is accurate value. Got it? So OLAP cubes consist of numeric facts called measures, which are characterized by dimensions. Now, quarter, product category, then territories or countries, okay, or cities, whatever. the OLAP cube is also called as the hypercube. What it is called? OLAP cubes are also called as hypercube. Clear? Understood? Yes. Usually, data operations and analysis are performed using the simple spreadsheet. Just now we have seen it. Usually operations and analysis are performed using spreadsheet in the form of Excel sheet which is having the rows and columns, where data values are arranged in a rows and column, like this. These are the rows and columns. The data will be arranged in this fashion. Got it? This is ideal for two-dimensional data. When we have the only rows and columns, that time it is fine. Okay, we can arrange them in a rows and columns. Okay, but OLAP contains multi-dimensional data. Online analytical processing consists of multi-dimensional data. As we have seen, one is product category, second one is quarters, time period, and here it is a territory. These are the three dimensions in this example. Got it? So it will be having OLAP will be contains multi-dimensional data with the data usually obtained from a different and under-related sources. So here now, data comes from different sources. Here OLAP is, that is nothing but a data warehouse where we get the data from the different sources. Using a spreadsheet is not an optimal option. Now this is not possible. Okay, with multi-dimensional values can be stored in the storing the things in the spreadsheet. It is not possible. It is not so easy. The cube can store and analyze the multi-dimensional data in a logical and orderly manner. So, in spite of that spreadsheet or Excel sheet or in the form of table, hello.
सर आपको स्लाइड नहीं दिखाई दे रहा है.
Slide change please sir. I don't see any other slide.
Slide is not visible.
No sir.
Visible sir, but only first slide visible.
Content is not visible.
हाँ sir, not.
Slide is not changing sir. Now it
Not
is
change sir.
changing.
First slide.
Just a minute. I'll do once again one thing. Okay, just a minute. Give me a minute. Data cubes, where I stored, yeah, here it is. Is screen is visible to you?
हाँ sir.
Now?
Yes sir.
Yes sir.
Is it visible?
Yes sir.
Okay, fine, good. Now, see, usually spreadsheet is not an optimal option. So, because in when you have the data in multi-dimensions, the spreadsheet is not an optimal solution or option, because you cannot, it is very difficult to store or represent the multi-dimensional data in the form of tables. So In spite of that, we are having the cube concept, which stores and analyze the multidimensional data. Okay, data cube that stores the datas and analyze the multidimensional data. It's data cube which stores multidimensional data and analyze the multidimensional data in logical and orderly manner. Orderly means the as per the thing. We have seen in the first slide here. After adding a first row, you will get the total sum of that. If you add the first column, you will get a different sum. Like this, you can get the information. Got it? Logical and orderly manner. Is the screen is visible to all of you?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay. Now I ask Sumaya, which are the various operations which can be performed on data cube? Sumaya. Is Sumaya is there?
Sir, multidimensional MOLAP, ROLAP.
No. I am asking operations. Operations, which operations can be performed on this? What is that? Data cube.
Roll up to drill down, sir.
Roll up, drill down. Slice and dice.
Slice and dice.
And
Slice and dice, sir.
okay, one more.
Pivot.
Pivot. Good. Okay. See here now. There are 4 operations, basic operations, which can be performed on the data cubes. The first one is roll up, because see here now, when we stored all the information in the data cube, okay, so we need to do some operations to get the information, right? These are the operations to get the information in a different angle, or in a different way. Okay, what type of information you need? Okay, so based on that, you will going to perform any one of these. I want only these 2 and perform this operation. I want a minute information. I don't want quarterly. I want it in the form of monthly basis, so that you perform particular operation. You only need a summarized information, then you perform this operation. Okay, now I need small information, then you get some only this thing, then you can only first in the what is that data cube. Okay, few dimensions are seeing. Okay, if you want remaining dimensions, you need to rotate it. Okay, so based on your requirement, you will going to perform any one of these operations. Got it? Now we will see one by one. What is roll up, drill down, slice and dice and pivot operations. Okay, now roll up operation. Roll up is also known as consolidation. Consolidation or aggregation means I don't want your subject wise result, sir. After your result, you will come and tell, sir, for this subject I got this much, and this subject I got this much, this subject I got this much. Okay, that time what I will tell, I don't want all those things. Tell me the aggregation, means overall result, or tell me the total. Okay, overall percentage of your this, means I am not interested in particular subject. I need information of the aggregate, means overall result of the thing. Got it? So first semester this much, second semester this much, third semester this much, fourth semester this much, like this. So after doing all these things, you will get an aggregation. No, I don't want your anything, so tell me the aggregate for percentage. Okay, so you will get all semesters will be added and take the percentage of that. So that will be the aggregation or consolidated result. Got it? Here I am not interested in particular semester or particular subject marks. Got it? So when you do the roll-up operation, you will get the consolidated result or the aggregated result. The roll-up operation can be performed in two ways. See, first all of you, when you need to perform the roll-up operation, so when you need the consolidated or overall result or consolidated data, I don't want in first quarter this much, second quarter this much, third quarter this much, fourth quarter this much. No. I don't want that. Tell me the total of that. Total is what? Aggregation, consolidated data. Got it? So this is when you want that kind of information. So go for this roll-up operation in the data queue. Is it clear now? Now this roll-up operation can be performed in two ways. First one is reducing the dimension. See here now, in roll-up operations, what we do? We reduce the dimensions. We reduce the dimensions. I don't want those things. I want only these things. So what I am going to do? I'll reduce the remaining dimensions. I'll highlight only one or two dimensions. Got it? Remaining dimensions will be there, but we'll not going to use them. I am not interested in those dimensions. Got it? Hence, I'll go to reduce the dimensions. Then, second way of performing this roll-up is combining up. Concept hierarchy means we combine the things. Concept hierarchy is a system of grouping the things based on their order or a level. Example I told, okay, when I need your aggregate result, what you will going to tell? What you will going to do? Okay, just you combine the result of first semester, second semester, third semester and fourth semester like this, and you tell me the overall result of that. Here, one first way, what you are going to do? You reduce the dimension. This is how you can perform the roll-up operation. Second way is combining the hierarchies, grouping the things which are required. Got it? These are the two ways you can perform the roll-up operation. We'll see one example now. We'll see one example. In this example, New Jersey. Okay, see here now, let me take. These are the cities. New Jersey is a city. Los Angeles is also city. Perth is also city. And Sydney is also city. These are the cities. This dimension is cities. Got it? Now, in this example, cities New Jersey and Los Angeles. Where are those? New Jersey and Los Angeles. These two cities, and roll up into country USA. Means these two cities are belonging to USA. So, in spite of displaying the city information, what I am going to do? I will combine those cities and get the information of the USA. Means there are, see, these two cities are Perth and Sydney are belonging to Australia, and these two are belonging to USA. So now I reduce the dimension here into cities into what? Country. I am going to reduce the cities into country. Hence I'll get, see, these New Jersey and Los Angeles belonging to this USA. Hence, as those things are belongings to USA, then this we are reducing USA. This is USA and this is Australia. This is Australia. See here now, there are 4 rows. Now those 4 rows are reduced into 2 rows. So we reduce the dimensions. We reduce the dimensions. After reducing, see here now, here this is, what is this? USA, and this will represent Australia. This will represent Australia. Now see here now, in first quarter, see, if you see here information, if you see this, can you able to see that figures, friends? Can you read those
Yes, sir.
figures? Are you able to read those figures which I have marked red here in this?
Yes, sir.
How much
Yes,
it
sir.
is? How much it is?
440, sir.
440. Very good. Then this is
1580, sir.
1560. How much it is?
156.
1560. Good. Your eyes are good. Okay. Now see, when you combine these two, so 440 plus 1560, it becomes 2000. It becomes 2000. Means in the first quarter, USA performed 2000. Whether it is dollars or money, whatever. Got it? It becomes, when you combined aggregated value of that country is 2000. What about Australia? See here now, here it is 395 in Perth, in Sydney it is 605. Okay, in Perth it is 395 and here it is 605. When you combine these two, okay, you will get 1000. You will get 1000 for the Australia. So hence, in the roll-up operation, what we are doing? We are reducing the number of dimensions. We are reducing the number of dimensions here. Got it? So I am not, for the same PC, book, shoe and clothes, item type, and these are the time period. Got it? Only I am reducing these cities into countries. When I reduce these cities into countries, so the number of dimension will be reduced. So in spite of 4, it is reduced to 2. Clear? This aggregation function process data is location hierarchy, moves up from the city to country. From city to country, it is moved up. Got it? It is moved up to cities to country. So it is like a zoom out. This operation is also called as zoom out. Zoom out means only the upper part you will going to see it. Got it? The upper part you will going to see it. Then in the roll-up process, at least one or more dimension need to be removed. At least one or more dimensions need to be removed. In this example, quarter dimension is removed. See here now, just I am looking for only first quarter of these two countries. Only this information I removed the remaining quarters. I removed remaining quarters. I am not interested in quarter 2, quarter 3, quarter 4. Got it? So I am interested in only this thing. Clear? Is this roll up operation is clear? All of you? Here we rolled up means roll up on locations from city to countries. Okay, now we move from city to countries. Every country will be having one or more cities. So those city values are combined into, so added to a particular value for the country. Got it? So this is roll up operation. This is the roll up operation. Is it clear? Understood? All of you?
Yes, sir.
Okay, fine. Now we'll move to drill down. Drill down, it is exactly opposite to the roll up. It is exactly opposite to the roll up. It is like a zoom in. Zoom in means, so whenever you want to see the minute detail, no, so you start zooming in, so that you will go in. and see the small thing. Got it? You will see the minute thing. Got it? So that is called as drill down. Drill down data is fragmented into smaller parts. Here we reduced cities into countries. So we rolled up into cities into countries. So first two cities are belonging to country. So I combined the data of those two cities and made one value, that is USA. And Perth and Sydney, I combined those two cities values and I made into that, what is that, this Australia value for the Australia country. Like this I rolled up. Exactly here we are doing reverse here. So we make smaller parts and see the details. It is opposite of the roll-up process. It can be done via moving down the concept hierarchy. See, this can be done in two ways. One is moving down the concept hierarchy and increasing the dimensions. What we do? We are moving down and see the details. Otherwise, we increase the number of dimensions and see the details. Got it? There what we do? We move up the concept and we reduce the dimensions. Here we are increasing the dimensions. We'll see one example on this. See here now. In this example, this is again same New Jersey 440 will be there, and this is Los Angeles is 1560 and Perth it is 395 and Sydney it is 605 for the quarter 1. These are all the values of a quarter 1. Now see here now. Here sorry this is for the quarter 1 PC. For this, what is this PC? Okay, personal computer is 605. For the book item it is 825 and for the shoe item it is 14 for the first quarter in the Sydney, and for the clothes it is 400 in the Sydney for the first quarter totally. So what I am going to do, I will take this only a quarter. I'll take this only a quarter, means this. Here in this quarter, what is there? January will be there, February will be there, March will be there. 3 months it will be there. Okay. So here this is 605 is including January, February and March. This similarly for 825, 14 as well as 400. Here I am going to increase the dimensions. In spite of quarters, I will reduce this into, increase this dimensions into January, February, March, April up to December. See here now, if you see the first dimension, first quarter, this is the first quarter. This is the first quarter up to this much, January, February and March. So what is the total amount in the cloths? That is 400. See here now, here it is now, here also for the cloths in the first quarter, I am seeing the details of January month, details of February, and I am seeing the details of March also. So 150 in the month of January, 100 in the month of February, and again 150 in the month of March. So all together it is 150 plus 100, 250, 250 plus 150, this is 400. So if you see first quarter, how much? For the cloths in the month, for the city Sydney, this is 400. Here also it is 400. Here we are getting the information in detail based on the months. Based on the month. Got it? See here we are having, what is this? Consolidated data. Here it is a consolidated data is again you drill down and see the details. If you go this, if it is this way, it is a drill down. Okay, if it's from this to this, it is roll up. Is it clear now? Understood all of you?
Yes, sir.
Yes.
Yes, sir.
Good. Next one is slice. Here one dimension is selected. You select any one dimension. Slice means you cut into pieces. Slice means you cut into pieces. Bread slices like this. So one dimension is selected and new subcube is created. So see here now, if I select from here to here, this and this much, see this is a red part, it is one cube. Got it? And I have separated only, what is this? These two cities are now Australia. These two cities belongs to Australia. Now I segregated these two cities in a different cube. It is one slice now. Okay. Another, this is USA. It is segregated into this city. Okay. So this is where, let me take color. Now this, this cube is blue colored, it is a for USA, and red colored is for this thing. Again here also those columns, cloths, items, everything will be there. Here also quarterly it will be there. The information will be same. But I have divided the cube into number of slices. And a new cube is created. When you slice it, okay, this is one cube and blue color is another cube. Dimension time is sliced here, see here now. In this example, time is sliced with a quarter 1 as the filter. See here now, what they did, only they have taken for this first quarter. What? Let me take a green color. Okay, they have sliced it into this is up to here. This is the first. This one. Okay, this is only first slice. Assume that it is a bread packet. Okay, first you slice. Okay, first slice if you remove it, no, that is quarter 1. Assume that there are 4 bread slices. First top one, it is quarter 1. Second slice of the bread piece is represents quarter 2, and third slice of the bread piece will represent quarter 3 and quarter 4 respectively. Okay, if first slice if you removed it, okay, you will get this. Okay, the city New Jersey will be there, Los Angeles will be there, Perth will be there, and Sydney will be there, and this again here in this PC, this will be item, book, shoe and cloth. So you will get this. So I removed the only information of the first quarter. Got it? That is one slice. Only I need a information of that slice. Okay, so this is how you can perform the things. Means you can make the cubes into number of slices. Here red color slice, it will represent you only Australia information. Okay, the blue color slice, okay, there you will get USA information. If you removed this way, like this, in this way, mehndi color, that slice, the top one, if you remove that way, top way, quarterly, so you will get the first quarter slice. See, based on, if you remove only this much, I will show you in different color. Okay, you will get a different information. You will get a different information. Where is green color? I will tell. Now, if I removed, let me take this only. If I removed this, if I remove this part this way vertically, I will get the information of the only PC item wise. See here now, here I removed, where is this? So stupid. Okay, this is PC wise. So I removed the only information of the particular item. If you bisect in the form of or slice, you made a slice in the vertically like this. Okay, you will get the information of the slice PC. Okay, first quarter, second quarter, third quarter, and fourth quarter in respective cities. Otherwise, if you do the slice in this, where is this? Like this, okay, see in this way, only this part, this part, then you will get, what is that? First quarter information. You will get first quarter information. If you remove this, see here now, based on your requirement, you have to, what do you need to do? You have to select the thing. See, if you take this way, if you make a slice in this way, you will get the information of the only PC, only the item PC. Got it? See, this is, if you want country wise or city wise, okay, if you want city wise information, just for this, you take this, only this, Sydney. Okay, it represent first thing, it will give you Sydney wise. Based on this thing, you can perform this operation, slice. Is this slice is understood? All of you?
Yes, sir.
Yes, sir.
Okay, if you're not understood, please ask. See here now, you can get lot many things over here in this cube. Lot of information you can get. Then next one is dice, slice and dice. Dice, you know it. Okay, for playing you will be having dice, no, which is having the 6 dimensions. Okay, in the same way we can, as I told, Perth, here it is. Now it looks like a dice. This country wise, it is a Perth and Sydney for the first quarters. The entire thing I have divided this into the, I am considering only this for the books and cloths. Where is that book and cloth, mobile phone, etc, etc, it is there. Okay, see now, see here now, here book is there, cloths is there, only I am interested in these 2 items, books and cloth. For the which quarter, see here now, see dice for location, I need a city Perth, I need a city Sydney. Okay, I am taking these 2 cities. Okay, and which time period you need? You need the information of first quarter and second quarter. So I am taking first quarter and second quarter. Then which items you need? I need the information of book and clothes. Then I took the book and clothes. So again this will form a dice. This will form a dice. Got it? So based on the information, which are all the things you need, okay, based on that you can make a dice. Make a dice out of it, and you can see it, and you can perform the various operation on this. You can perform slice operation, you can perform you can perform roll up, you can perform drill down, all these operations, or you can perform pivot operation on this also. Got it? Because it is again a small dice, it is a cube. Got it? This operation is similar to a slice. The difference in the dice is you selected 2 or more dimensions. Yes, here you must, in this actually we took 2 dimensions. Here no, we should take only this way. Either you can cut into horizontal way, this way, or you can cut into this, like this. But you cannot take more than one city, or you cannot take more than one quarter, like this. Okay, I cannot take Australia and USA, we have segregated, no. Okay, but here you can take which are the things, okay, more than 2 dimensions. That results in the creation of subcubes. We have created subcube here. Got it? So subcube means more than one slices you can consider. Got it? This is what the dice. Hope you understood what is slice and dice. Is it clear? All of you?
Yes, sir.
Yes, sir.
Yes, sir.
Last operation is pivot. Last operation is pivot. Pivot means you rotate the data axis to provide a substitute presentation of data. Presentation of data. See here now. This is how actually it is there. Now in the cube, here cities will be there in row wise. Okay, this represent the cities, these represent the cities or locations, and here columns represents items. These columns represents items. Now I'll rotate into, or I'll pivot into this way. So I can take this way. Items will be in the row and the locations will be in the column. See here, this New Jersey, Los Angeles, and all those things comes in column headings, and these things comes under row headings. So we can rotate based on your requirement. Okay, this is all about the various data cube and its operation.